Okay, so we have two functions here. We have f of x is 3x. We have g of x is the 11x minus 5. So everywhere where you see the f of x, you're going to plug in, you're going to substitute in the 3x. So right there where the f of x is 3x, you're going to add it to the g of x. So we have 11x minus 5. Just combine your like terms. So we have 3x plus 11x, which is 14x minus 5. And that's it. Can you do that on a test? All right. When you are subtracting, make sure that you know you're subtracting a binomial. So you're going to have to distribute that subtraction sign to both of these terms. So for your f of x, we have 3x, and we're subtracting 11x minus 5. That's where you distribute. So we have 3x, subtract the 11x, and then a negative times a negative is a positive. So we end up with a negative 8x plus 5. Can you do that on a test? All right, f of x times g of x. So we have 3x, and we're going to multiply that by the 11x minus 5. Distribute. We end up with 33x squared. 3 times the negative 5, that's a negative 15x. Can you do that on a test? So we're feeling pretty smart then, right? Okay. F of x over g of x. 3x over 11x minus 5. You can only reduce when you can factor out. So you're looking to see if in all three terms you have a common factor. Do we have a common factor in all three terms? No, so you can't reduce it. We can state the restriction. So you take your denominator, 11x minus 5, and we know that it can never equal a 0. Add your 5. Divide by 11. So this shows me that my restriction is that x can never be 5 over 11. If it was, it would make me have a 0 on the bottom, which is mathematically illegal, right? All right. Now we're at compositions. So we start on the inside. The inside function here is g of x. So we are going to substitute in the 11x minus 5 for the g of x. So we're looking at f of 11x minus 5. Some of you were getting confused on this. We're using the f function. Where the x is, we are going to substitute in for that x value. So think of it as taking the x out and putting our new stuff in its place. So it's 3 times 11x minus 5. 3 times 11x, 3 times the negative 5, just distribute there. We end up with 33x minus 15. How are we doing? Good? Okay. Inside first on the f of x, what are we plugging in for f of x? Substitute in 3 of x. Now, on the g function, do you see where the x is? It's 11 times x minus 5. So instead of 11 times x, we're going to take the x out and substitute in 3x. So it becomes 11 times 3x minus 5. 33x minus 5. Feeling smart? Okay. Can you do that on a test? If you can't, you need to come in for some help, right? All right. Finding the inverse. When you are finding the inverse, what is the first thing I want to do? I have a y, I have an x, I'm going to switch them. I need to solve for y. I need to isolate y. So what do I need to do to both sides here? Okay. So I have x plus 3 is equal to 10y. And then? So now I have y equals x plus 3 divided by 10. The original is a linear function. The inverse is a linear function. So since they're both functions, we're going to use function notation. F negative 1 of x is equal to x plus 3 over 10. Ta-da! Got it? Okay. Then your favorite, fractions. What do I do first? Switch the x and y. X equals 1/4 x, oops, 1/4 y plus 3 over 4. I need to isolate the y, so what am I going to do? Okay, I now have x minus 3/4 is equal to 1/4 y. The coefficient of my y is 1/4. I need to isolate my y. So I need to multiply by the reciprocal, which is 4 over 1. And that's just 4, right? So distribute here. 4 times x is 4x. Distribute here. 4 times 3 over 4. The original is a function, linear function. The inverse is a function, a linear function. Doesn't have to be linear, just as long as they're both functions. So since they are both functions, we're going to use the function notation f negative 1 of x is equal to 4x minus 3. Beautiful. Y equals 3 over 5x. Switch your x and y. What do I need to multiply by? 5 over 3. So y equals 5 over 3 x. Now the original is a function. The inverse is a function. So you use your function notation. F negative 1 of x is equal to 5 over 3 x. And that is it. Okay?